Hello friends, this is Anand Pai from Academy in Pursuit of Engineering Excellence. Today we will continue with our series on problems on students recommendation. Today the problem which was recommended is XEB 2016 question number 11. Let us solve this. The question is like this. A jet of diameter 20 mm and velocity 6 meters per second coming out of water tank standing on a frictionless car hits a vane and gets deflected by 45 degree as shown in the figure below. The density of water is 1000 kg per meter cube. Neglect all minor and viscous losses. If the cart remains stationary, the magnitude of tension in the supporting string connected to the wall is dash. Let us solve this. Now first of all, here what we have to see is what is the equation we have to use. We have to use the Newton's law, which is given by force is equal to, we can write it as m dot into delta v. Now when we take delta m dot, it is generally rho av. Now here this velocity, what should we take? We have to see, and then v2 minus v1. Now when I take delta t is final minus initial, I am calculating the force applied on the fluid rather than on the vane or the trolley. Okay. So now here if I take this is rho av into v2 minus v1. What is v2? v2 we have to take it along the string, because we have to see what is the forces along the string. We are not worried what is the force which is exerted up like this. Okay. Now this force which is exerted up is on the fluid rather than on the vane. We have to understand. Now we are only related to fluid we are doing. Okay. So it is rho av into what is v2? v2 can be written as, because we are taking only the x-axis, v2 can be written as 6 meters per second cos 45. Now the question is, what should we take for this v? Now v is the relative velocity, or the what is the amount of mass which is flowing on the vane, and for that the mass which is flowing is 6 meters per second itself. So we are taking this as 6 meters per second. So this would be rho a, instead of v it is 6 meters per second. So this has to be taken as 6 meters per second and 6 cos 45. Now let us apply a and v. Rho we will apply the thing. We will say density is 1000, area is, I can say, pi into 0.02 square by 4 into, I can say, 6 square into cos 45. So the answer what I will get is 7.99 Newton. Now what is this? This is the force exerted by the vane on the fluid. What would be the force exerted by the fluid on the vane? So this is, so by the fluid on the vane would be equal to minus 7.99 Newton. And what is the force exerted by the string on the trolley to stop it? It would be equal to plus 7.99 Newton. So the answer is plus 7.99 Newton would be the answer. I hope you have understood this, students. If you have any doubts, comment it. I will make a video and I will post the clarification for that doubt also. So best of luck, students, for your exams. Thank you very much.